Hello, everybody. Wow. I hope when you guys see this, it's very grainy. I'm just pixels. So welcome to sixth grade science. This is week 26. So I have really enjoyed the last 2 weeks getting some feedback from you guys. I've seen lots of emails and pictures of the experiments that you did on your own. You guys have created some super cool thermoses, thermi, whoa, don't wiggle. Um, Very ingenious, really. I'm super impressed. And if you haven't had a chance yet to send me an email, just even jot down a couple of things that you thought, your observations, or how you had that work. And then your thermometers. It was really cool to see some of the experiments that you guys did with your thermometer and what you had on hand at your house. Some of you had didn't have the exact supplies, but you made do with things that you do have in the house. I think you're all, I love your science minds. I love your how inquisitive and curious you guys were in and then trying to figure it out and do some experiments, and a couple of them failed, and then you tried it again. And I loved hearing those results and seeing kind of how you thought through that whole scientific process of what your hypothesis was, performing the experiment, making some notes, seeing what you could do different, how could you adapt it. This didn't work when I used this liquid or that liquid, like on the thermometer, for example, and you tried something else to see how it works. So I'm really proud of you guys. And like I said, if you haven't had a chance yet to send me a video of you either doing the experiment or maybe what your results were, or just jot me down some of your observations. I love it. And maybe in a week or so, I can compile a few of those and I can share those with you, and you can see what some of your friends and schoolmates are doing for science. So we just finished, those last 4 weeks were on energy and matter. So we're going to set that one to the side, and now we're starting a unit on weather and climate. So I think one thing that's cool about doing weather and climate right now is, what is the weather like in the spring? What's it like? It's crazy. Your moms and dads probably joke. I know I feel like sometimes it is a joke that we have like every season or multiple seasons just in one day. So whenever you're watching this, where I live the last couple of days, or even over last week, one day it was beautiful. We went outside, it was sunny. I felt like I was getting some vitamin D from the sun, and then went to bed and woke up the next morning, there was snow on the ground. Windy, then beautiful the next day, pouring rain. So we get to see a lot of weather changes in the spring. So as we talk about weather and climate the next 4 weeks, you guys should be able to see a lot of this with your own eyes, not just through experiments. So be cognizant of that. Look around, see what's going on with the weather. Take a second and look and see what you notice. Or if you go on a ride or something, look and see, look for some of the things that we've talked about. So it's one of the really cool things about Utah is that we get 4 distinct seasons, and sometimes 4 seasons in one day. Sometimes it happens. So what we're going to talk about today is the water cycle. Now, the water cycle is something that you guys have done almost every couple of years. You talked about it at length. So now as a 6th grader, we're really going to put some of that knowledge, that base knowledge that you've gotten, we're going to put it to the test, and you guys are going to do an experiment on your own. If we were in class, we would do this all together and break out into groups and do some observing and do some changing the variables here and there. But you guys get to be the scientists and perform this experiment on your own. So the first thing that you should have done when you got the file is there is a at-home water experiment piece of paper. It has all the instructions on it. You can either print it and have it there for you, or you can just pull it up and have it visible as you're doing your experiment. But there's quite a few supplies that you need. So you need to make sure and look through all of those supplies. You need a clear, clear shoebox. Or a lot of us have like food storage containers, Tupperware, Rubbermaid in our cupboards that might have a, about this deep and looks like a shoebox. something like that. Or you could use kind of a large glass bowl that has maybe a little bit of a, see my hands right here, a little bit of a flat bottom. It comes up, so you'll be able to do this experiment. You need some space, but look around. I guess you could use a 9x13 glass pan. That would probably work too. I didn't think about that until right now. But get all of the supplies out that you need. There's quite a few. And then when we're done with this video, this one's going to be pretty short. It's all on you. You are the scientist, and you're going to perform this experiment. And then I would love to hear about how it went. Take a couple of pictures. Tell me how, if it didn't work. And what do we say in science when it doesn't work? We say, great. How are we going to learn if we get everything right every single time? Things have to fail, or we would never end up with something awesome, like electricity, or in my class we were talking about all the great failures. Whoa, if I move, that resulted in something great. A lot of times it has to do with food. Would have never had this food if somebody hadn't goofed up and had a crazy thing. So think about that when you're doing your experiments. If it totally flops, that's great. What do we learn from it? What could we do different next time? You know, maybe it's not a good idea to use this ingredient for that. So that's how we learn. It's awesome. So we're going to watch a video. Like I said, I know you guys have hit a lot on the water cycle. I think 4th grade is the year where there's really quite a bit on it. So you guys have a really good base knowledge of it. But what I want you to do is I want you to think for just a second about the water cycle, and really think about some of the scientific words that go along with it. You know, we can say things like, in fact, in the video it says even grade school kids, well, you guys are great, little kids, they know what the water cycle is, right? Rains, goes down to the ground, goes up, and goes back around. It's a circle. That's why we call it a cycle. Think about what some of those scientific words are. So while you're watching the video, if you have your piece of paper and your pencil handy, I want you to jot down a couple of the kind of those scientific definitions about the processes. Yes. I'm not going to push pause because now I'm going to have the giggles. About the process of the water cycle. What are some of those like the scientific terms, instead of just saying rain, water, goes back up? Don't use some scientific terms. So I'm going to share a video with you guys, and we're going to watch about the water cycle. I got to be able to get my mouse to work here. Let's share a screen, people. So before, oh, well, let's back it all the way up, people. Nope, back it up. Oh, goodness. Okay, back it up even more. There's Tom. Tom, we're not ready for you yet. Okay, so before this starts, it's 6 minutes. You guys are good. So get your piece of paper and your pencil out, and I want you to jot down a couple of notes, and I want you, what you're looking for are scientific terms for the process, processes. I hope you guys are having fun. You gotta laugh sometimes, right? I've done a lot of videos today. Blah, blah, blah. I want you to write down the scientific terms for that take place during the water cycle. So let's use our 5th and 6th grade brains and write some of those down. If you have any other ideas or observations that come out of this video, maybe something you never thought of before, or you knew it, but the way it was explained was like, no, oh wow, that totally makes sense. So let's watch the video on the water cycle. Jot down those notes that you have on the scientific names, and then we'll just do a fast review of the video, and then we'll go over the experiment. Are you ready? I know you're ready. I can see all of you on the, just on the edge of your chair, just ready.
All the water on Earth today, every drop, is all the water there has ever been on the planet. Fresh water is actually millions of years old, the same water flowing in a continuous loop, falling as rain and snow from clouds to the Earth's surface, running in rivers, pooling in ponds, flowing from faucets, irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle. So simple, even small children understand the basics. Yet so complex, the most advanced Earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time, and yet we don't really understand it.
How to summarize what is known about the water cycle? With 2 words, flows and stores.
Flows
The water
and stores.
cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere.
There's always a little bit of water in the atmosphere. We talk about relative humidity. It's a humid day, it's a dry day. Either way, there's water, sometimes a little, sometimes a lot.
There's a lot of water in the ocean, 70% of all the water on Earth. In the ice sheets and glaciers, 2/3 of all the fresh water on Earth. In the snowpacks atop mountains like the Sierra Nevada. In the Great Lakes, in rivers and streams, in reservoirs and watersheds, in wetlands, in the soil, in and on plants and trees rooted in the soil, and beneath the soil, in water tables and underground aquifers like the Ogallala High Plains, which runs underneath parts of 8 states from South Dakota to Texas. All this storage is temporary. Water in all its forms is always in flux and always moving. And there is a name for every kind of movement in the water cycle, starting with precipitation.
Precipitation is the process of water falling onto the surface of the Earth. You can have precipitation in many forms: rain, snow, hail.
Rain is falling water in liquid form. Snow, ice, hail, and sleet are falling water in solid or frozen form. Fog and mist, falling water in gas or vapor form.
Are you guys writing things down?
Precipitation that falls directly onto the oceans becomes part of surface ocean and can be churned by wave and wind action into ocean currents. Rain and snow that falls directly on rivers and streams becomes one part of stream flow. Rain that falls onto land takes a different path to the river, as does the snow and ice that falls and collects on mountaintops when temperatures warm.
When snow melts, some of it runs through the snowpack and goes into small streams, tributaries that feed into large rivers.
What about that precipitation that falls on and over land? Some is intercepted by vegetation, plants, and trees.
Like you might imagine someone in the game of football intercepting a pass. These are raindrops trying to come to the ground, and the leaves on the tree intercept them before they hit the ground.
And the precipitation that does hit the ground, it can run off if the ground is hardscape, covered with asphalt or concrete, or if the soil is too wet or saturated to absorb more water, like an over-soaked sponge. Otherwise, precipitation infiltrates the soil surface, percolates into the ground.
Think of it as the water percolating through your coffee grounds in the morning. Gravity continues to pull it downward so it will move through.
Through the topsoil, into spaces between soil and rock particles, down to bedrock and further into fractures, into deep underground aquifers. Even groundwater here is moving sideways or laterally, discharging toward a river, lake, or the sea. Generally, the deeper the flow, the slower the flow.
Some of that fractured water might take a very long time, thousands to millions of years to get out.
And how does water get back out into the atmosphere? It evaporates, is turned from a liquid into a gas or vapor by the heat of the sun.
If you put a bit of water into a bowl and you set it outside on a sunny day, it's going to disappear. It's still water, it's just in the form of a gas rather than the form of a liquid.
Water evaporates from every wet surface, even from wet air. Some rain and snow evaporates into the air while falling. Water evaporates through our respiration and perspiration, and from plants through transpiration. Trans means through or across. Plant roots draw up groundwater.
And plants pull that water up through their stems into their leaves and then release it back out through evapotranspiration.
Evapotranspiration, a spelling bee-worthy term for evaporation from soil and water surfaces, plus transpiration from plants. Evaporated water molecules are tiny enough to flow into the air, mix with smoke and dirt particles in the atmosphere, cool, condense into visible masses of water vapor, clouds.
Condensation?
Winds move clouds into colder air, water droplets collide and merge, grow bigger and heavier, until they are so heavy they fall again, as rain or snow, sleet or hail. Precipitation, collection, runoff, interception, infiltration, percolation, discharge, transpiration, evaporation, condensation. The water cycle.
All right, you guys, did you hear all of those big scientific words? That's what I was talking about. So when we talk about the water cycle, like I said, from that very first picture that had a child's drawing of the water cycle, we could all do that. We all know, right? We see it with our own eyes. We know it. We've learned it. We start using some of those big scientific terms. I like the one where she said it's a spelling bee worthy. Honestly, it would be. That would be a hard one. So as you're doing your experiment, I want you to think about those words and what they mean. So I'm just going to give you a really quick definition, or a really quick review. So I'm going to have to read it so I get all the words right. But we know that all of the water that, all of the water that has been present, or all the water on the earth today has always been present. So whether it's currently precipitation or evaporation, all the water has already been here. So Earth's water supply is recycled in a continuous process known as the water cycle. Water molecules continuously move from location to location in this cycle. And do you guys remember in the video what they called that? Can you remember? The water cycle is important to weather and climate, and ultimately to all life on Earth. What would we do without the water cycle? If the water was gone, once it evaporated and that was it? Right now, we try really hard to conserve water. I know we talked about that several weeks ago with conservation a little bit, and how to make sure, we did the experiment with how much of the Earth's water is usable and what we use it for, and how it really opens your eyes to waste. So what if it was gone? What if once it was gone, it was gone? So we know that it continues to recycle. So the water cycle is driven primarily by energy from the sun. So we've talked a lot about that too, the energy from the sun, those rays that come down. It drives the cycle by evaporating water from the oceans, lakes, rivers, and even the soil. Other water moves from plants to the atmosphere through the process of transpiration and evapotranspiration, right? Isn't that what it was? I can hear something upstairs in my house really loud, so sorry. Got a little distracted. As liquid water evaporates or transpires, it forms the water vapor in the clouds, where water droplets eventually gain enough mass to fall back to Earth as precipitation. The precipitation then becomes runoff or groundwater, and it works its way over various time scales, different ways, different places, back into the surface reservoirs. And then the water cycle is essentially a closed system. So it just keeps happening and happening. There isn't like, oh, some water went over there. Oh, did you guys see? I'm a Da Vinci dragon. Maybe I already said that. So here's the way it's going to work today with the experiment. So make sure that once you're ready, you've gathered all your supplies. Let's open up the document here real quick. I forgot to close down that video, so I got to get us out of that. And let's open up the, okay, so if you've printed this out and you're looking at it, otherwise, who wants to listen to it again? No. Let's just shut that down. Okay. So these are going to be your instructions. So I'll just go through them really quick with you. So you're going to need that plastic shoebox, food storage container. Like I said, you could use a last glass bowl or a 9x13 pan. Oh, I did think of it before. Yay, so smart. You're going to need plastic cling wrap. So this is not aluminum foil. This is plastic wrap that you would put over something and put it in the fridge. You need rubber bands. Now you're going to need to be able to seal, you're going to put the plastic wrap over this container, and you need to be able to make sure that it can hold the weight of some ice that you're going to put on top of it. So my suggestion is if you only have maybe just a couple of little tiny rubber bands or very small rubber bands, if you cut a couple of them apart and tie them together, you could make a larger rubber band to go all the way around. If you happen to have a couple of really large rubber bands, you might only need one or two, or maybe you have those really big rubber bands and one will snap over the top. But you need to be able to hold that plastic wrap securely in place over your container. And even though cling wrap clings, it's never perfect. And it doesn't, could you hear that? It never clings perfectly onto plastic. That's why we need the rubber bands. And my suggestion too is if you do need a second sheet of cling wrap, like one and then two to really hold it, you can try that too. That could be a variable in your experiment that you work with. You need some really warm water. Now, I need you to make sure that mom and dad give you permission to not only heat it up and how you decide to heat that, if you need to do it in the microwave or if you happen to just do it out of the tap, but you need it to be pretty hot, pretty warm, and you're going to use that as part of your experiment. So please make sure that that mom and dad, that you know what's going on there, that they're going to be working with some hot water, some warm water, and you're gonna need to be able to pour that. So make sure you got permission. Don't anybody burn themselves. You need like a jar lid or a really small bowl. So when we're talking about a jar lid, like a salsa jar or a pickle jar, that's like that big, that round, just enough that you can put something there. You know, I don't want you to go put like a whole bowl in there. This is kind of a mini experiment. But if you do have just a really small bowl, a teeny little shallow bowl, like a little custard dish, something like that, that can work too. Again, this could be one of the variables that you experiment with to see what happens. You're going to need a little Ziploc bag filled with some dirt or sand or pebbles. So if it's okay with mom and dad, go outside, grab some dirt, put it in that sandwich-sized Ziploc bag, zip it up. Maybe you've got some sand or some little pebbles around, but you're going to need that. So just a little sandwich-sized bag of that. Then you're going to need a larger Ziploc bag filled with a couple of cups of ice, maybe at least a cup or two, because you really need that cold and with the hot water, because we've got to make sure that we have the extremes in temperature. So I would say maybe 1 to 2 cups of ice, and seal it in that Ziploc bag. Like I said, you may need a gallon Ziploc bag, a little bit bigger. Now this next one says focus light source. It's just a big way of saying you need a lamp. You need a lamp to shine down on this, because the lamp is going to act as your sun, as your solar energy, and you need at least a 40 or 60 watt bulb. The very best thing that will work is a desk lamp. You know, those kind of desk lamps, and they're the kind that they have at the beginning of the Pixar movies, right? That smashes the ball. That's open like that. If you have a lamp on the side of your desk that's just a regular lamp, you could probably take the shade off, but you need something that's going to give you some focused light to act as the sun's rays for this experiment. My kids have those clamp-on ones that they put on their bed. That would work great too. Just make sure that you've got a light source like that. Now you always want to make sure that you never turn it on or have it in a way that you could burn yourself or have it touching the plastic wrap or the container. You don't want to melt anything. So just be conscientious of that. And then the last thing is, if you have a couple of drops of blue food coloring, that would be great. You could drop it into the water in the bottom of your pan to make it look like actual like ocean water. So it's blue, might be a little easier to see. Okay, so let's just go through the instructions real quick. I know you can read, but we're going to go through them together. So you want to add enough water to fill the bottom of your container. So I would say between 1.5 to 2 inches deep. It's got to be deep enough that when you put the other things in there, that there's enough water to actually do the experiment. So not just a teeny bit, but you know, a good amount. Then this is where you could add the food coloring, mix it in and see, make it a little bit more like ocean water. I guess if you want to do any other color, knock yourself out. So then you're going to place the bag of sand or dirt at one end of the container. So this is going to represent land. So you'll put it, so if your container's like this, you're going to put it all the way down at one end. It's not at this end, so all the way down at the end. It has to sit above the water level too. So if you just fill it a tiny little bit of dirt, then if it sits below the 1 or 2 inches of water, you're either going to need to do a little less water, or you're going to need to fill your bag up a little more. So you got your land mass down there at the end. Then you're going to set your little jar lid or bowl on top of the land mass. Again, this is why you want a little tiny, something that's tiny that will fit in there. This is where you start to cover. So number 4, you're going to cover the container with plastic wrap, and you're going to secure it tightly with the rubber bands. So I gave you kind of a tip on the rubber bands. If you cannot find any rubber bands and that's just something that you can't work, my suggestion would be some tape. Hold it really tight, get another set of hands and run the tape around there so it's very secure. Because if you set the ice on top of the plastic and it's not secure to the container, what's it gonna do? It's gonna sink right in, and that's not part of the water cycle. The bag of ice doesn't fall. Oh, look, over there. So make sure it's really secure. Rubber bands are great. If you can think of another, if you use your ingenuity and you can think of another way to really make that secure, go for it. Let me know what it was, and I'll add that to our experiment notes. So now you're going to set the bag of ice on top of the plastic wrap directly over the jar lid. So directly over the jar lid on top of the landmass. So your other half of the box is going to be alone. You're going to leave it alone. Everything is down at one end. Number 6, if you set your lamp up, you're going to set it up at the opposite end from the landmass, away from the landmass and ice. And you're going to direct the light either down through the top. So if you have one of those bedside lamps, study lamps, having a hard time thinking, you know, where you can kind of crane the neck, you want it to shine down through the top like the sun rays, but you remember you're on the opposite end from the landmass. If it's another kind of lamp, maybe you could set it and have it shine through the side, depending, here, there's my arms, you know, shine through the side. So one way or the other, you need to have those sun rays coming through that opposite side of the plastic container. So, and like I said, do not let your lamp touch the plastic wrap or the container or it will melt. And I don't want you guys to have any problems with that. So it doesn't have to be super, super, super close. It just needs to be close enough that that is acting like the sun to your water cycle experiment. Now, as you go down, you've printed this. If you've printed it, you're going to be able to fill it out completely. If it's something you don't have the ability to print, these questions, I need you to copy down on your separate pieces of paper that you have. So you are going to now, what's a hypothesis? What is a hypothesis? In my class, it comes out fast. Educated guess. Put your educated guess down there. What do you think is going to happen? You've got the setup, you see the supplies, you've got the ice, you've got the warm water in the bottom, you've got some landmass in there, and you've sealed it. What's going to happen? I want you to write it down. Give your guess. Now comes your observation. So as the experiment is taking place, now this is something that isn't going to happen in like 1 or 2 minutes. You're going to have to give it just a little bit of time and really observe. So I want you to answer these questions. Some of them we may have given away just by my talking. Some of them from the video, but look at the different questions. Why did we do this? What would happen if we added an extra light? What if it was in a dark closet and there was no lamp? So look through those questions and I want you to answer each of those questions. I would love to see these answers back. You can take a picture of those or you can scan it and email it back to me. I want to see the answers to those questions. Let's get out of this now. Okay. So you're on your own for this one. I want you to perform this experiment, make sure you've got permission to work with the hot water and that you have all the supplies that you need. If you need to make some adaptations with the supplies, just do the best that you can with what you've got. But pretty much we should all be able to get our hands on some dirt and some sand or rocks, hot water, plastic wrap of some kind, and see some kind of lamp and see what happens with the experiment. Get that second page filled out and send it to me. That would be great. And then if you have any other observations, if you want to do a couple of, if you want to change a few of the variables and maybe see what happens if you did put it in a dark closet, or if you had, you know, think about some ways that you can change it. I would love to hear those observations. Okay. Good job. Go for it. And I can't wait to hear about it. Okay. We miss you guys. Everybody stay happy and healthy, and I will see you soon.